Welcome everyone. It is 3 p.m. and it's time for the server room show. This is episode 78. Today let's call this the third part of, well, actually they are independent episodes uh, in the series where I talk about Oberon, Plan9, Inferno and other operating systems which were inspired by these two, Oberon and Plan9. In episode 76, I talked about Oberon. The full episode was about Oberon. In episode 77, I said pretty much everything about Plan9. There is a slightly little bit is left for this episode, where we talk about Acme text editor and the impact of Plan9, and we will close this episode talking about the influence and the impact Plan9 had on other operating systems it inspired. The Acme text editor is pretty much as strange for me for use than Emacs was when I tried it. It claims to be more than just a text editor, and I'm sure it is. For me, it's like I said, it's a strange beast, just as much as Emacs is. But nevertheless, I believe that it's very powerful and everything. It adds to the fact that, as we mentioned, that Plan9 and Oberon as well relies heavily on mouse action, mouse clicks, and working with the mouse instead working only with the keyboards and keyboard shortcuts. I think it added to the complexity of it when I tried it in a virtual machine. I tried 9 front. I will mention 9 front a bit later. Acme is a text editor and actually a graphical shell from the Plan9 from Bell Labs operating system, designed and implemented by Rob Pike. It can use the SAM command language. The design of the interface was influenced, as we said previously, by Oberon. It is different from other editing environments in that it acts as a 9p server. A distinctive element of the user interface is this mouse chording thing I've mentioned or I described. Acme can be used as a mail and newsreader or as a front end to WikiFS. These applications are made possible by external components interacting with Acme through its file system interface. Rob Pike has mentioned that the name Acme was suggested to him by Penn Jillette of Penn and Teller during a movie night at Times Square when he asked for a suitable name for a text editor that does everything. A port to the Inferno operating system is part of Inferno's default distribution. Inferno can run as an application on top of other operating systems, allowing Inferno's port of Acme to be used on most operating systems, including Microsoft Windows and Linux. A project called Acme standalone complex intends to make Acme run as a standalone application on the host operating system. Working port of Acme for Unix-like operating systems is included in Plan9 from user space, a collection of various supported programs from Plan9. Currently it has been tested on a variety of programs, variety of operating systems, including Linux, Mac, the BSDs, Solaris and Sun OS as well. The impact of Plan9 Plan9 demonstrated that an integral concept of Unix, that every system interface could be represented as a set of files, could be successfully implemented in a modern distributed system. Some features from Plan9, like the UTF-8 character encoding of Unicode, have been implemented in other operating systems. Unix-like operating systems such as Linux have implemented 9p Plan9's file system and have adopted the features of rfork, Plan9's process creation mechanism. Additionally, in Plan9 from user space, several of Plan9's applications and tools including the SAM and acme editors, have been ported to Unix and Linux systems and have achieved some level of popularity. Several projects seek to replace the new operating system programs surrounding the Linux kernel with the Plan9 operating system programs. The 9WM window manager was inspired by 8.5, the older windowing system of Plan9. VMII is also heavily influenced by Plan9. In computer science research, Plan9 has been used as a grid computing platform and as a vehicle for research into ubiquitous computing without middleware. In commerce, Plan9 underlies Core 8 storage systems. However, Plan9 has never approached Unix in popularity and has been primarily a research tool. It looks like Plan9 failed simply because it fell short of being a compelling enough improvement on Unix to displace its ancestor. Compared to Plan9, Unix creaks and clanks and has obvious rust spots, but it gets the job done well enough to hold its position. There is a lesson here for ambitious system architects. The most dangerous enemy of a better solution is an existing code base that is just good enough. This statement was from Eric S. Raymond. Other factors that contributed to low adoption of Plan9 include the lack of commercial backup, the low number of end-user applications, and the lack of device drivers. Plan9 proponents and developers claims that the problems hindering in adoption have been solved, that its original goals as a distributed system, development environment and research platform have been met, and that it enjoys moderate but growing popularity. Inferno, through its hosted capabilities, has been a vehicle for bringing Plan9 technologies to other systems as a hosted part of heterogeneous computing grids. Several projects work to extend Plan9, including 9atom and 9front. These forks augment Plan9 with additional hardware drivers and software, including an improved version of the UPass email system, the Go compiler, Mercurial version control system support, and other programs. Plan9 was ported to the Raspberry Pi single board computer. The Harvey project attempts to replace the custom Plan9 C compiler with GCC to leverage modern development tools such as GitHub and Coverity and speed up development. Derivatives and forks. Inferno is a descendant of Plan9 and shares many design concepts and even source code in the kernel, particularly around devices and the STIX 9P2000 protocol. Inferno shares with Plan9 the Unix heritage from Bell Labs and the Unix philosophy. Many of the command line tools in Inferno were Plan9 tools that were translated to Limbo. 9atom arguments the Plan9 distribution with the addition of 386 PEA kernel and AMD64 CPU and terminal kernel, NUPAS extra PC hardware support. 9front is a fork of Plan9. It was started to remedy a perceived lack of devoted development resources inside Bell Labs and has accumulated various fixes and improvements. 9 Legacy is an alternative distribution. It includes a set of patches based on the current Plan9 distribution. Akaros is designed for many core architectures and large-scale systems. Harvey OS is an effort to get the Plan9 code working with GCC and CLang. Yahan OS is an experimental OS derived from Plan9. Its userland and modules are mostly derived from 9front. Its build system from Harvey OS and its kernel is a fork of the Plan9 9K64-bit Plan9 kernel. Nix is a fork of Plan9 aimed at multi-core systems and cloud computing, and Plan B designed to work in distributed environments where the set of available resources is different at different points in time. Inferno, the Inferno operating system. Inferno is a distributed operating system started at Bell Labs and now developed and maintained by Vitanova Holdings as a free software. Inferno was based on the experience gained with Plan9 from Bell Labs and the further research of Bell Labs into operating systems, languages, on-the-fly compilers, graphics, security, networking, and portability. The name of the operating system and many of its associated programs, as well as that of current company, were inspired by Dante Alighieri's Divine Comedy. In Italian, Inferno means hell, of which there are 9 circles in Dante's Divine Comedy. The history of Inferno a little bit. Inferno is a descendant of Plan9 from Bell Labs and shares many design concepts and even source code in the kernel and the Unix philosophy. In the mid-1990s, Plan9 development was set aside in favor of Inferno. The new system's existence was leaked by Dennis Ritchie in early 1996 after less than a year of development on the system, and publicly presented later that year as a competitor to Java. At the same time, Bell Labs' parent company AT&T licensed Java technology from Sun Microsystems. In March-April 1997, IEE Internet Computing included an advertisement for Inferno networking software. It claimed that various devices could communicate over any network, including the Internet, telecommunications, and LANs. The advertisement stated that video games could talk to computers, a PlayStation was pictured, cell phones could access email, and voicemail was available via TV. Lucent used Inferno in at least 2 internal products, the Lucent VPN firewall brick and the Lucent Podstar phone switch. They initially tried to sell source code licenses of Inferno, but found very few buyers. Lucent did little marketing and missed the importance of the Internet and Inferno's relation to it. During the same time, Sun Microsystems was heavily marketing its own Java programming language, which was targeting a similar market with analogous technology that worked in web browsers and also filled the demand for object-oriented languages popular at that time. Lucent licensed Java from Sun, claiming that all Inferno devices would be made to run Java. A Java bytecode to this bytecode translator was written to facilitate that. However, Inferno still did not find customers. The Inferno business unit closed after 3 years and was sold to Vitanova. Vitanova continued the development and offered commercial licenses to the complete system and free downloads and licenses, and not GPL compatible licenses for all of the systems except the kernel and the VM. They ported the software to new hardware and focused on distributed applications. Eventually, Vitanova released the source code under GPL license, and the Inferno operating system is now free, libre, open source software project. The design principles. Inferno was created in 1995 by members of Bell Labs Computer Science Research Division to bring ideas of Plan9 from Bell Labs to a wider range of devices and networks. Inferno is a distributed operating system based on 3 basic principles drawn from Plan9. Resources as files. All resources are represented as files within a hierarchical file system. Namespaces. A program's view of the network is a single coherent namespace that appears as a hierarchical file system but may represent physically separated locally or remote resources. Standard communication protocol. A standard protocol called STIX is used to access all resources, both local and remote. To handle the diversity of network environments, it was intended to be used in the designers decided a virtual machine was a necessary component of the system. This is the same conclusion of the Oak project that became Java but arrived at independently. This virtual machine is a registered machine intended to closely match the architecture it runs on as opposed to the stack machine of the Java virtual machine. An advantage of this approach is the relative simplicity of creating a just-in-time compiler for new architectures. The virtual machine provides memory management designed to be efficient on devices with as little as 1 megabyte of memory and without memory mapping hardware. Its garbage collection is a hybrid of reference counting and real-time coloring collector that gathers cyclic data. The Inferno kernel contains the virtual machine on-the-fly compiler, scheduler, devices, protocol stacks, and namespace evaluator for each process's file namespace and the root of the file system hierarchy. The kernel also includes some built-in modules that provide interfaces of the virtual operating system, such as system calls, graphics, security, and math modules. The Bell Labs technical journal paper introducing Inferno listed several dimensions of portability and versatility provided by the OS. Portability across processors, it currently runs on ARM, SGI MIPS, HP, PA RISC, IBM PowerPC, SunSpark, and Intel x86 architectures, and it is readily portable to run on others. Portability across environments, it runs as a standalone operating system on small terminals and also as a user application under Plan9, Windows NT, Windows 95, Unix, IRIX, Sun Solaris FreeBSD, macOS, Linux, IBM AIX, HPUX, and even also True64 Unix. In all of these environments, Inferno programs see an identical interface. Distributed design, the identical environment is established at the user's terminal and at the server, and each may import the resources, for example, the attached I/O devices or networks of the other. Aided by the communications facilities of the runtime system, programs may be split easily and even dynamically between client and server. Minimal hardware requirements. It runs useful applications standalone on machines with as little as 1 megabyte of memory and does not require memory mapping hardware. Portable programs. Inferno programs are written in the type safe language Limbo and compiled to this DIS bytecode, which can be run without modifications on all Inferno platforms. Dynamic adaptability. Programs may, depending on the hardware or other resources available, load different program modules to perform a specific function. For example, a video player might use any of several different decoder modules. These design choices were directed to provide standard interfaces that free content and service providers from concern of the details of the diverse hardware, software, and the networks over which their content is delivered. Some features. Inferno programs are portable across a broad mix of hardware, networks, and environments. It defines a virtual machine known as DIS that can be implemented on any real machine. It provides Limbo, a type-safe language that is compiled to portable bytecode, and more significantly, it includes a virtual operating system that supplies the same interfaces whether Inferno runs natively on hardware or runs as a user program on top of another operating system. A communications protocol called STIX is applied uniformly to access both local and remote resources. which programs use by calling standard file operations, open, read, write, and close. As of the 4th edition of Inferno, Styx is identical to Plan9's newer version of its hallmark 9p protocol 9p 2000. Most of the Inferno commands are very similar to Unix commands with the same name. Ports. Inferno runs directly on native hardware and also as an application, providing a virtual operating system which runs on other platforms. Programs can be developed and run on all Inferno platforms without modification or recompilation. Native ports include x86, ARM, PowerPC, Spark. Hosted or virtual OS ports include Microsoft Windows, Linux, FreeBSD, Plan9, Mac OS, Solaris, Unixware, IRIX. Inferno can also be hosted by a plugin to Internet Explorer. Vitanova said that plugins for other browsers were under development, but they were never released. Inferno has also been ported to OpenMoko, Nintendo DS, Shiva Plug, and Android. Distribution. Inferno 4th edition was released in early 2005 as free software. Specifically, it was dual licensed under two licenses. Users could either obtain it under a set of free software licenses, or they could obtain it under a proprietary license. In the case of the free software license scheme, different parts of the system were covered by different licenses, including the GNU General Public License, the GNU Lesser General Public License, the Lucent Public License, and the MIT license. Subsequently, Vitanova has made it possible to acquire the entire system, excluding the fonts, which are sub-licensed from Bigelow and Holmes under the GPL version 2. All three license options are currently available. A little bit about 9 Front and 9 Legacy. 9 Front is a fork of Plan9. It was started to remedy a perceived lack of devoted development resources inside Bell Labs and has accumulated various fixes and improvements. Whereas 9 Legacy is an alternative distribution, it includes a set of patches based on the current Plan9 distribution. So, in my understanding, 9 Legacy is kind of like trying to be as true to the roots as possible and continue this legacy, so to say. While 9 Front is as it said, it's a fork of Plan9. So 9 Legacy is the more pure in my understanding, and 9 Front is actually a fork which not as close to the original as possible. That's my take and my understanding of it. You can, however, find a lot of information on both 9 Fronts and 9 Legacy's websites and can read more about it. And definitely the 9 Front one is full with information, with additional informations. It's sometimes even too much, I would say. Harvey OS and Yehan OS, both inspired by Plan9. Harvey OS's description from its own website states that Harvey is an effort to provide a modern, distributed 64-bit operating system, a different environment for researching and finding new lines of work. It runs on x86-64, AMD64 machines. Main work is focused in improving the kernel and userland, trying to bring up a full usable operating system with common tools for development and the USB installation image. It collects many different ideas and concepts that across many platforms and operating systems influenced the computing world for years. Yehan's OS description from their website, stating that Yehan is a simple operating system. It shows that few orthogonal abstractions can be composed to provide everything you want from a modern operating system and more. A vision for simplicity. Yehan is named after a peasant girl that was burned as an heretic and then canonized as a saint. Everybody can see why it's a heretic OS. It breaks many traditions of Plan9 from Bell Labs. It challenges some design decisions and even breaks some common conventions rooted in Unix. There is no /bin folder, there is no sleep system call, there is no swap. Markdown replaces troff for documentation. GCC is the default compiler. 9p 2000 is still supported but replaced. However, the point of this research is not to disrupt well-established habits, but to pursue a vision for simplicity. Beware, there is no glory for simplicity. Everybody can do it after. The more with less approach. Yahan is simple in many different ways. The kernel API is minimal and uniform, 26 system calls, control devices, memory, IPC, scheduling and namespaces. Everything is a file, really, even directories. The default file system provides a clean taxonomy. The project scope includes a minimal system, compilers, editors, browsers, games. Many useful softwares can be ported to Yahan through lib-POSIX and newlib, and it mentions that soon Musl, MUSL as well. Also, Yahan is a free software and it will always be. The kernel and all their tools are GPL version 2 and everything new is AGPL version 3. It is not only formally open like many other projects from big names. You are welcome to challenge the assumption and prove them wrong, and even remove the code if you want to. You just have to make it both simpler and more useful. So, like this, we have reached the end of a journey through these 3 episodes we did. A bit separate on each. Episode 76 was about solely about Oberon. Then episode 77 was dedicated to Plan 9, and episode 78 we talked about in this episode Acme text editor, let's say the legacy of Plan 9, Inferno, what came after, and some other operating systems which were inspired by Plan 9 and Inferno, we can say. So you can treat them as a 3-part episode, or in my opinion they are three different episodes, but closely related to one another. I would not say that they are strictly 3-part episode, because the content is nicely divided between the 3, so you can enjoy them separately. You don't need to know the previous episode, so to say. But yeah, again, 3 important pieces put down with Oberon, Plan 9 and Inferno. I definitely should spend some more time on 9 front or even on Inferno, and try to explore these operating systems a little bit more. As always, there is so much to do and so little time to do them. But yeah, I will try to spend some time with them, and I will see you next Saturday with something else, with something new. I don't even know what it's going to be just yet, but I try to keep it interesting and interesting and fun for you people to listen to it. I don't know. It will be definitely something which I want to talk about. Sometimes I have good ideas, so to say, but then I realize that, oh wait, my format is so to say strictly audio only format. So maybe I want to talk about something which requires a lot of showing something visually, and then I realized that okay, so it's gonna be difficult to do only with my voice, only by talking about it. So yeah, sometimes I get great ideas, but then I have to throw them out because of the restrictions of this format of the podcast. But that brings also the good part, that it's fun in the sense that it limits you in one way, but forces you to be more creative or more or find different material which is better to be presented in an audio only scenario. So yeah, it has its ups and downs. Thank you very much for listening, and see you next Saturday.